right? And so, are you measuring it from something, or is it just giving you information, a category that it fits into? So we're going to get more practice with it, but that's what I want you to be aware of, is those two types of data that we will study. Yes, Gracie?
Can that be like a trick question type thing, like just by the way you word the question?
I will be nicer than that in assessments and things. If I were to ask you how many years has it been since World War II, that's a measurement,
Yeah.
right? If I just ask you what year did blank happen, that year is a category. Yeah. Does that make sense?
Yes.
That's a good thing to note, right? How many, right? Am I measuring it, or just in what year, right? Okay, so there's our types of data, but we also need to be aware of statistical versus non-statistical questions. So I'll go ahead and tell you, this group right here are non-statistical questions. And this group over here, would be considered statistical questions. What are your predictions about why? So I'll give you 60 seconds, and I just want you to think for a little bit so you can engage in this conversation, right? Remember, I don't want to hear from the same students every single time. I want everybody to get engaged. So 60 seconds, think about why those two are, on the left are non-statistical and the two on the right are statistical. 60 seconds starts now. Nope, individually, sorry. Actually, I'll do this. 30 seconds to think on your own, then 30 seconds to talk. I think that's fair. All right, your 30 seconds of think time are over. 30 seconds to talk with your group. Come up with a prediction.
Ooh, that's a good one.
Thank you, thank you, thank you. All right, so let's hear from group 4. Start us off. What did y'all figure out, or what did y'all discuss about why groups A and C are non-statistical and B and D are statistical? Just get some ideas out there.
A and C, we only one way to describe how many dimensions they have and what type it is.
Okay,
But B and D, you can show it in different
okay,
graphs.
okay. Anybody want to push back or add on to that information?
Going off what she said about B and D, everyone's gonna have a different opinion about their types of chips, and not every bag of chips has the same way.
Okay. Is that a true statement? That everyone's going to have a different type?
No.
Not everyone's going to have a different type, but will there be differences in people's types?
Yes.
Will there be differences in the number of chips in a bag?
Most likely.
So what you're saying is that there's variability there?
Yeah.
Is there variability within these the responses to this? What type of chips? I mean, but if I ask you what type of chips these are, there's only one response, right? If I hold up a different bag of chips and I say, hey, what type of chips are these? It's still only one answer. There's only one correct answer, right? Like, people could give other answers, but they would be wrong. So here's what makes a non-statistical question non-statistical. There is not expected to be variability. I could probably word that better, my bad. But basically you don't expect there to be, let's say it that way. You, sorry for switching it, don't expect there to be variability in responses. I should have just said variability is not expected. Oh, it's fine. I'll fix it on this one. So with statistical questions, variability is expected in responses. Yes, ma'am.
So we use the word expect, is there ever a chance that there will be variety in
There will be variability and it's not expected. I will say this, you will never not expect variability and then there will be there, but there are times when you may expect variability and there is none. That's why it's worded that way. So for example, if I were to ask, I'll hold off actually, there's a question I have already built into the lesson that'll clearly explain that idea, right? So it's all about whether variability is expected or not. But I will give an example of each of these. So if I were to ask you, hey, how many students are in my third block Algebra 2 class? The correct answer is 26. That's never going to change. Well, I mean, I guess that could change, but as of right now, it's 26. But if I were to ask you, hey, how many students are typically in class? Is that 26? No. Because sometimes we have people that are absent, right? And so that's kind of the difference there. The same, I'll stay away from that. But yeah, that's where we get into the idea of like, do we expect there to be variability in responses? No, the only correct response is that there are 26 students in my Algebra 2 class. How many are actually here every day? That has variability in it. Questions, comments, concerns? We will get practice with these ideas in a second. Okay? There's a table there, guys. So, what is statistics? This is kind of an important question that you need to be able to answer. I mentioned it earlier. It's not a pure math, right? It's actually a mathematical science. Well, what do we mean by science? What is science?
That's a good question.
That is a good question, right? How have the theories and the laws of science been developed? We study things, we've done experiments, right? So to have an experiment, to do a study, you have to have a what first? You have to have a hypothesis, right? And so with science, you have hypotheses, and then you develop studies, you develop experiments to investigate those hypotheses, to figure out if that hypothesis holds up. Statistics is a lot like that. We're going to develop hypotheses and make predictions based on the information that we have. We're not proving anything, but we are going to develop hypotheses and make predictions. And so with that, what we're really going to focus on is the idea of representing and analyzing data. Y'all have done math literacy probably every year you've been at Hillcrest, which is like a small little smidge of what statistics is. We're going to actually look at why does statistics matter, but it'll also cover our math literacy thing, so that'll be nice, right? Please notice the last question right here is, what story does the data tell you? That's the real question with statistics. What story does the data tell you, okay? By the way, I know y'all are probably used to lecture like this is just to pose questions. You didn't have to write this down. I was just giving you a heads up. We're going to talk through a handful of things that you don't have to have written down at this point. I'll tell you when you need to start writing stuff down again. So right here, I don't know how many of you knew Gracie when she was at Hillcrest. I think I had her 2 years ago. Yeah, 2 years ago. Maybe I had her 3 years ago, and the students who did this study I had 2 years ago. But it was the year of COVID that it hit. Gracie Vanderford was a senior that year, and she made a statement, or apparently she made this statement regularly to her friends, that she knew 70% of Hillcrest High School. They're like, she could go and talk to 70% of people and know their names. And so my friend, or not my friends, my students, her friends, didn't quite believe her. And so they developed a study for my AP Stats class. And this is the data that they collected through that study. Now, I want to point this out. First off, are they going to go and ask or have Gracie identify every single student at Hillcrest High School by name? Why not?
So that's like 1,000 kids.
Yeah. That's way too many students, right? That's impossible. And so one of the things we need to be aware of, and one of the things we're going to do early on, is we're actually going to look at, okay, so how do we collect data so that we don't have to do everyone, but we can still get a good picture of what's happening, right? And so one of the biggest things to start with statistics is, well, how do I collect good data? And we'll get into that in a second. But when they collected the data, which I will confirm that they did a great job with it, when they collected the data, what they did is they had a yearbook and they used what's called a random number generator to randomly identify students in the yearbook, and they showed Gracie just the picture, covered up the name, and said, what is this person's name? And apparently, which I'm wicked impressed by this, she knew 85% of the seniors by name. That's impressive. In a graduating class of what, 350, 370, somewhere in there? That's impressive. And then even when it came to the juniors, she got about 65%, 63, 64. So at that point, you know, you might believe 70%. But then it got down to the sophomores and she only knew 35% of those students. Now, they only did seniors, juniors, and sophomores because they used a yearbook from the year before, so no one had pictures of the freshmen. But based on this data, do you believe Gracie that she knew 70% of the students at Hillcrest?
It's that story.
I mean, like, legitimately, I want you to think about it. She knew 85% of the seniors, about 63, 64% of the juniors, and about 35% of the sophomores.
Yeah.
Do you believe that she knew 70% of the students at Hillcrest?
Mm-hmm.
Well, I would average them, because they're percentiles, right? Think about it. If you were to average 85 and 65, that would give you about 75%, right? It doesn't work exactly that way, but that's about 75%. But if you average that then with 35%,
Just like 60.
that's going to drop it down a good chunk. And notice how she knew fewer and fewer the younger they got. So freshmen, maybe 20%. So do you really think she knew 70%?
Probably like 50%.
Maybe. That's still impressive, right? I have no clue how she did that. But I want you to notice that this is what statistics is all about. I'm not going to ask her to look at every single student at Hillcrest and have her identify what the student is, but if I can collect a good sample, if I can collect good data, I can make a prediction off of that. That same year, Ainsley Campbell, she was a super overachiever, and she was in National Honor Society, and she was getting frustrated that students weren't showing up to the tutoring that NHS offered every single week, and so she actually conducted a study to figure out why. Notice she didn't create a graph like these students did, but she did create a table here, and she used other statistical inferences. And when she did this, and she investigated, what she found out was, right, so she kind of ignored the A's and B's because those students really didn't need tutoring much, right? But she looked over here at the C's through F's. What's the top reasons why students didn't stay for tutoring?
Embarrassed and uncomfortable.
Right. So can't really do much about unable to stay due to conflicts, but we got to figure out a way to address that idea of being uncomfortable and embarrassed to go to tutoring. Because no one should ever be embarrassed to say that they need extra help and get the help that they need to be successful, right? And so that's what she said, and she tried to make changes. Unfortunately, COVID ruined that, right? So this is what we want to be aware of, that there's a story being told, but we got to go collect the data. And we need to investigate, what is that story? And I bring all this up, and here's another example, I'll go into this in a second. I bring all of this up because whether you're aware of it or not, data is all around you. There's always something being said on TikTok or Instagram or news articles, things like that, where, well, there was this % of people affected by blank. There was data all over the place when COVID first started hitting, and it was causing mass panic and hysteria. And then some people are like, oh, the data is just lying, blah, 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 blah. Well, no, we can't just say this is stupid or it's not. We got to investigate the data and know how to investigate the data and investigate the studies that develop the data. Data will be around you for the rest of your life. So it's important that you understand how to analyze it, how to interpret it, how to read it. And so that's what we're going to spend time on. One of the things I will point out is this. So one of my buddies, David Dye, teaches down in Mobile County. This is some graph that he developed for his students to analyze. These are ACT scores for the 2018 to 2019 year of Mobile County schools, right? This specific type of graph is known as a dot plot. Really simple, but really effective. You'll see I have another example of a dot plot back here, something I used to do with my students in my statistical class. This is a dot plot of the year of pennies. I have the pennies somewhere, but I went through and I made a dot plot of every penny that I had in a tub, and we did stuff with it. But these are dot plots, and so when I look at this information, each dot represents a school in their average ACT, right? So whatever school this is, their average ACT is a 16, right? These two schools, what's their average ACT? 15. So what story is this graph telling us?
Most schools average around 17.
Okay? Do most schools average a 17?
No,
That there is a term for the one that has the most, that occurs most commonly. It's called a mode. So the mode of this data, right, for these schools is 17. But what would you say? May not say the most, but I might say a typical average or a typical ACT score might be what?
18.
I would say the majority probably are 18 or below, but I'm asking for a typical ACT score. What's a word that we used earlier for a typical number? An average, right? Well, yeah, we have about half of our data down here, but we also have a decent chunk up here, right? So where would the average be?
In the middle.
Kind of somewhere in the middle?
19.
Maybe around a 19, right? Okay, so there's a story here, and we want to notice, oh, well, a typical ACT score in Mobile County is roughly a 19. I could find out exactly what it is, but based on that data, somewhere around a 19. But it's definitely not centered at 19, or it's not perfectly 19. Is there a good bit of variability, change in the responses for each school? And so we'll learn about how to measure that variability as well. The last thing I want to point out is this. These are the scores for Mobile County. Do you think that we could use this data to make a prediction about the state of Alabama?
No, it's too low.
Not just that one? Why?
You need more than one. That's not enough.
You might want more than one county, right? So remember, when we looked at whether Gracie Vanderford knew 70% of students, could we look at just seniors to get a full picture? No. Did they just ask about one particular student? No. You need more data, but we need to learn how to know the correct amount of data to collect. And we also need to recognize that if I want to make a prediction about the state of Alabama, I need data that is representative of the state of Alabama. Mobile alone isn't going to represent the entire state. Even a more extreme case, would Mobile County tell you about the entire United States?
No.
No. It's just one data point. And so we're going to learn how to collect data in such a way that we can make a prediction about our state, or about the country, or about blank. And that's the thing of statistics, is it's taking data and figuring out what story it tells, figuring out, okay, what can I figure out as a result of this? What prediction can I make? And that's what we're going to do with data. So here's what we're going to do, though. We're going to talk about the statistical and non-statistical questions again, just for a little bit. And so I'm going to send out a poll question. Now that I've given you like a little background of, hey, this is why we're studying stats. Here's a poll question, right? Which question or questions are not statistical? Right? Talk about it with your group, but let's take 60 seconds to 2 minutes, 1 to 2 minutes to answer this question. Which question is not statistical?
No group, you said.
You can talk to your group.
The other two are really asking. You can make a graph, like the graph, you can make a graph of it, but there's only one right
Yeah, you can discuss this with your group. I would come up with an answer together. Come up with an answer together. Deja, have you participated in that discussion? No? You agree? Oh, you were reading. Gotcha. So here's the thing, like, it sounds like y'all two are talking pretty well, but y'all are each other, right? All three of us need to be discussing. Okay.
You know what all we gotta do today?
No, Thursday we're not.
Okay, 30 more seconds.
Oh, uh-oh.
Okay? So, remember, we got 25 students in class. We got to make sure we answer it. There we go. Okay, so question 3. Vast majority of us are saying question 3 is the non-statistical question. What is it about question 3 that makes you think it is not statistical?
You can't graph it and there's only one right answer.
Great, Sam.
They said class.
The same answer is expected.
The same answer is expected. Do y'all agree with that statement?
Yes.
Yeah, how many blocks have there been before this math class?
2.
2. So what's the other word that I've talked about and used each time? If that we expect the same answer every time, that means there is no variability, right? There is no expected variability to that response. Questions, comments, or concerns? Okay? Would that be numerical or categorical data?
Categorical.
Numerical.
Oh.
It's how many, right?
So numerical.
That'd be numerical. I know it can get tricky sometimes, but you're asking how many of something is there. You're counting them, which is a form of measurement, right? A count is a form of measurement. All right? This first one up here, on average, how many letters are in the family last name for students in this class? Obviously, we all think it's statistical. Is it numerical or categorical?
Numerical. Wait, I'm lying. Categorical.
It's what?
Categorical.
It's categorical?
Numerical.
Numerical? Say that one more time. Brief. It's asking for an average, right? If you're averaging things, you're dealing with numerical data. They're not fitting into a category. Yes, you're counting those number of letters, but that is a measurement, okay? One thing I will point out, because this came up as an issue for students later, please hear me. This is the question that we're trying to answer, but is this the question I would ask if I was talking directly to a person? No. What question might I ask directly to a person to try to figure out this answer?
How many letters is our family?
There we go, right? So this is known as a survey question. What y'all are saying right now, so how many letters are in your last name? Do I expect variability to a question like that?
Yes.
If it's a survey question, yes. Please note that difference, right? If it's a survey question to answer this question, yes, there's definitely variability, right? But if I were to ask the question, how many letters are in Grace Ann's last name, is there variability in that?
No.
No.
Oh.
So be careful, right? If you're asking specifically to somebody, that's a survey question. That has variability, right? But again, if I ask Marlon, hey Marlon, how many letters are in your last name? Or how many letters are in Marlon's last name? How many correct answers are there? Only one. That's the difference. Is it a survey question to a specific person, or is it just a question about that person in general? So be careful about that. So which month has the most birthdays from the class? Categorical or numerical?
Numerical. Categorical.
Numerical.
I'm hearing a lot of categorical, I hear numerical. I will say this, the survey question might help you answer this. What question would you ask to help you answer this question? What month is your birthday? Clay, what month is your birthday in?
February.
So is that a number or is that a category?
That's a category.
So it's categorical data.
Let's go.
Alright, notice we would collect the frequency of those responses, so there would be numbers involved, but the survey question is going to collect categorical data. So let's do a second version of this. Here are some more questions. I'm going to send this question back out. There we go. So which question or questions is not statistical?
Can we talk with groups again?
Yep.
Okay. I agree because it's the reverse of last time. Is this the reverse of last time? This is what I answered last time. So yeah, that'd be up there. On what?
Does that make you? Makes you price? Yeah. Price.
No, I'm 16th place. That's all.
So after 16.
16th and after.
Yeah. Yes, ma'am. Which question? This should say is/are, meaning like there could be more than one.
And my sister, and my dad, and my mom.
Thank you. Thank you. Thank you. Okay. Didn't get all 25 students to respond. Guys, I need you to remember that you're supposed to be actively collaborating in class. But unanimous at that point. Question 3. So what makes question 3 not statistical? There's only one answer. Anyone know that year? I was not really. I was informed earlier that it's 1868. I thought it was 1869. You know, it's close. But yeah, 1868. The 13th Amendment was ratified.
What is that?
The 13th Amendment? Anybody know that response?
I know Kanye said it in a song.
That's one of the Bill of Rights.
Kanye said it in a song. Is
I should know this.
it the slavery one?
Yes,
It's the
Slavery one?
guarantee of rights to slaves.
So why did he say that?
I don't know how he worded it in the song, but I'm yeah.
Oh my gosh.
So it was freedom for slaves. Anyways, categorical numerical data for question 3. I'm just asking y'all right now, was this categorical or numerical? Right, in what year, right? So the year that it occurred in is a category. On average, was the furthest in miles that each student in this class has ever been from home? Numerical, right? The number of miles, that's a measurement. Would the class rather have a snow day or a field trip day?
Categorical.
That's categorical. And I will point out, what is the survey question you would ask with number 2 to figure out the answer?
Would you rather have a snow day or a field trip day?
Right. Would you rather have a snow day or a field trip day? And what I will point out is this. I mean, and we may have, Ali, I think you were the one who was asking about the wording of variability earlier when I was defining it, right? So I don't know for sure. My assumption would be that y'all would rather have a snow day because if I don't have to come to school, I don't want to come to school. But this is an example where we could get all the same responses. But is there a possibility to have more than one
Can we
response?
test it out right now?
Right.
Actually, you're saying.
I mean, it
Test it out?
depends on the person, and it also depends on what the field trip is.
Let's test it out right now.
Not always.
Mr. King.
I hear what you're saying. I can see what you're
So
saying.
field trip, you're here.
Aaliyah, you might need to go get that. You definitely want that. Okay, so that's the reason why the wording is expected variability, because we may not have any variability. If I were to roll a die, it's not likely, but it's a possibility that I could roll a die and get a 5 every single time, right? It's not likely. A dice. Dice is plural, die is singular. Sorry. So if you were to roll a singular die, it's not likely, but you could get a 5 every single time. Well, there is no variability, but did I expect there to be variability when rolling a die with 6 sides? That's the difference, right? Did you expect variability? It's not whether you got variability, just did you expect it? So we're going to skip this one. So here's what I want us to do. I'm going to give you another poll question where you actually get to create your own question to see how well we're understanding this. Just 2 minutes. Create a statistical question that would need numerical data. A statistical question that would need numerical data. I don't want a survey question. I want a statistical question that would need numerical data.
By yourself?
Yeah, this one on your own. Thank you for that clarification. So this one's solo. You develop your own question. Huh? What? Oh, area code. Zip code. Zip code versus area code. Beginning of a telephone number. I got you. By the way, you can get to question marks. The question mark is in the bottom right-hand corner of the calculator, right next to the G.
Oh, yeah, it opens up all that stuff.
All right, let's pause here. I know that we're not quite done, but I think we have enough questions to have a discussion here. So please understand, like, this is not an assessment, or it's not an assessment with a grade. This is just to help us get some ideas out, right? So on average, how many students eat from the lunchroom? So how many students eat from the lunchroom versus how many bring their own lunch? Okay, let me ask you a question. What's the survey question you would ask with that?
Do you bring your lunch or do you eat in the lunchroom?
So is that numerical or is that categorical?
That's categorical. No, it's not. It's
Categorical.
So even though it has the how many in there, so notice we can't really do an average actually with this. So we want to learn from that.